Who's ready for the last notes of chapter 2? Pick me, pick me. Okay, here we go. 2-9, combined and joint variation. Moving right along. Objective and what's the point? I feel like this ties everything together. Okay, we're going to find equations that describe certain data that we're given. And we're going to have to find k when more than one independent variable comes into play. This is super important because our job as mathematicians is to look at data and analyze it. We are in the business of making predictions. And I'd say 90% of the time, things don't depend on one independent variable. For example, plants, like if you're doing plant heights, we know that it depends on how much water they get, how much sunlight they get. I don't know, like soil type. I'm not a science person. But it depends on more than one thing. So this is going to tie the relationship of more than one variable together. Super duper important. I like it a lot. Okay, let's move on here. Words to know. Combined variation is when both direct and inverse occurs. Take a look at these formulas. Notice, up here we got a direct variation relationship. M, whatever that is varying directly with W with T squared. But it's varying inversely with D because D is on the downstairs here. Same thing with S, it's very directly with R and F and inversely as B. They're both showing up. They're fancy little equations. Joint variation is different. That's only direct all the way, but there's more than one direct relationship. V equals 3.14 HR squared, both direct, and Y equals KXE, all direct. Notice this K is always showing up. K, 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 and in this case they have a value for K. Alright, super fun. I like it a lot. Okay, to find K in combined variation, you have to find one instance that you can relate all the variables. Just like when we did sections 2.1 and 2.2. You're looking for that case where you can plug everything in so you can figure out what K is, because that's super important. After you find K, then you plug it back into the original equation and you can make predictions all day long. Very similar to 2.1 and 2.2, just a little bit more complicated algebra. Okay, we have lots of examples. We're getting bookwork problems here. I will give the answer first so you don't have to wait except on this first page, because this first page, by the time I write the answer down, we could have figured it out anyway. We are now going from language to equations and equations to language. T varies directly with H and inversely as the cube of n. Don't lose exponents here. Okay, T varies, so T equals, don't forget your K, directly with H, so that gives me KH. Inversely, that means downstairs, cube of n, n to the third. T varies directly as H and inversely as the cube of n. We did it. Okay. A varies jointly. Remember, jointly means direct all day, so this is all going to be on the top. A equals, because A varies, don't forget your K, as B, C, and the fourth power of D. B, C, and the fourth power of D. We did it. Okay. Now we're going to take the equation and we're going to write it with words. The formula for the volume of a right cone is V equals 1/3 pi r squared h, where r is the radius of the base and h is the height of the cone. We are going to write it using variation language. Okay, notice up here we have K. This time they actually tell us the K, but we don't have to put that into our words. Okay, so we're going to start with volume, or V. If you would have put V, that would have been fine. Volume. Is this all direct or is this combined? What do we got? It's all direct, so we could say volume varies jointly as what? As the exponent here, as a square of the radius and the height. Some people might think that I'm leaving some information out because I did not give the 1/3 pi, but that's why question B is asking what is that constant of variation, and that would be 1/3 pi, or you could put pi over 3 if you like. Alright, moving right along. This time we're actually in the business of finding values. We're going to actually be plugging some things in, finding some K values. Okay, Z varies directly as the square of X and inversely as Y. This is combined because the words direct and inverse both show up. So we're going to write a general variation equation first, and then I'll give you the answers after that. So Z equals, don't forget your K, k x squared over y. All right, so I will go ahead and give you the answers here for, maybe if I can find them, okay, I have 7.36 here if you want to go ahead and work it on your own, and 31.403. I will now work them out. Here's a piece of information that I plug in to figure out what k is. Z, x, y. It relates all the variables. So now I will take 18.4, because that is my z value, equals, I'm looking for k, so that still shows there, x squared, that's 2 squared, all over y, which is 1.6. Okay, we're going to get k by itself, so you have some options here. I like to clean up my equation first, so I'll go with 18.4 equals 4k over 1.6. Now I got to get k by itself, so I'm going to get rid of this fraction. I'm going to multiply both sides by 1.6. Remember, we need to do it to both sides to keep things equal. I'm going to break out my calculator here on 18.4 times 1.6, and I get 29.44 equals 4k. Looking for that k value, so I divide both sides by 4, and I get k equals 7.36. Don't round that. Some of you had issues on your quiz about rounding that k value, and that does mess up some of your calculations later. So keep as much of k as you can. I will now plug that back into my equation. So now I have z equals 7.36 x squared over y. The B question just asked for the constant. We are now going to make a prediction off of, we're figuring out what z is when x is 3.2 and y is 2.4. So z is what I'm still looking for. This is just evaluating expression, really. 7.36 times 3.2 squared all over 2.4. This is a straight calculator problem, and I should get what they told me I'm going to get, but I'm going to double check. 7.36 times 3.2 squared. Enter. Make sure you hit enter first, because you get quite a big decimal there before you divide it by 2.4. And I get 31.40, and that was actually rounded value. I had 31.40 to 66 repeating bar, it looks like, so the 6 was repeating. Okay, that was fun. I know I had fun. I hope you did too. Chances are maybe not as much fun as me, but that's okay if you don't want to be a math teacher. If you really had a good time with that, maybe consider being a math teacher. Okie dokie, artichoke. Next one, I will go ahead and give you the answer for those of you who are bored and waiting. I get the answer of about, it says approximately 20.7. So let's see how we do it. P varies inversely as a square of m and directly as r in the cube of j. So the most important part of this problem is to write that relationship first. Inversely is a square of m, so m squared is going to be down below. Don't forget your k up here. Directly is r. And the cube of j cubed. This is the piece of information relating all the data right here. R is this, j is this, m is this, p is this. Looks like a doozy to plug in, but we will go ahead. 12 equals k times r is 180, j to the third is 2.1 to the third, all over 19.4 squared. Okay, since I have all these decimals and exponents, I'm actually not going to clean it up first, because I'm just going to have to round a whole bunch of decimals, which would take away from my accuracy. So on this one, I'm going to go ahead straight and get rid of the fraction by multiplying both sides by 19.4 squared. I didn't do the 19.4 squared first on this one, just because I knew it wouldn't work out very nicely. So I get 19.4 squared times 12. I have 4,516.32 equals this mess. Okay, so I'm going to get k by itself. When you do this, guys, I'm going to call it. You're going to make a mistake here. I really hope you don't. But this is going to give you some issues when you plug this in your calculator if you're not careful. Okay, divide both sides by 180 times 2.1 to the third. You do have the option of getting a single value here if you think that will help you out. Just make sure that you keep as much as possible for accuracy. So now I have k. When I type this in, I'm typing 4,516.32, which should actually already be in your calculator. Divide by parentheses. Group this value here, because the whole 4,516 is being divided by all of this. So divide by 180 times 2.1 to the third, caret 3, in case you don't remember. Then you're going to close those parentheses. And I have 2.70928, blah, blah, blah. Not even done with this problem yet. That's just my k value. I plug that back into the equation. Let's go up here now. P equals, keep all that junk in your calculator. RJ to the third. There's a show about RJ Burger on TV, I remember. M squared. Okay. Find P, good, whenever I'm looking for all this other stuff. So the good news is I'm looking for P, so I can leave that K in there that I already have, that 2.709. I'll just put a box around it so that I know I'm talking about this nonsense. R is 144, so I'll take that value that's already in my calculator, times 144, times 2.6 to the third. Then I will hit equal, people. Hit equals first before you divide by 18.2 squared. If you don't hit equals first, then you need to use parentheses when you do the 18.2 squared. So really be careful. So I have that big nonsense in my calculator, times 144 times 2.6 to the third. Enter. Divide by parentheses 18.2 squared. So excited, drum roll please. I got 20.7 and it was 011.3. Blah, blah, blah. That was fun. Okay, good times. I like it. Next one, 6 and 7 under certain conditions. Let me see if I can get you the answers here. This is 750 horsepower if you want to work it on your own. And 7 will be about 306.8 pounds. Okay, so let's go ahead and work it. Under certain conditions, the thrust of a propeller varies jointly, remember jointly means directly, as its speed s measured in RPM and the square of its diameter d measured in feet. Suppose the propeller blah blah blah. Okay, these can sometimes be overwhelming when you look at it. There's a lot of words here and a lot of information. Just notice, as soon as you see varies jointly, say, okay, well, first thing I want to do is come up with my equation. So I stopped reading after I figured out where my equation was. I encourage you to do that also. So my equation is going to be T equals jointly, so it's all direct, K, speed of S, and square of a diameter squared. I got all that from that first sentence right there. Now I'm going to jump in and look for the information that relates them all together. Suppose a propeller 4 feet in diameter generates 600 horsepower of thrust at 1000 RPM. Okie dokie. So T. What was T? T was the thrust. Thrust. I don't even know what thrust is. I guess thrust must be horsepower since I'm stupid, and S is RPM and diameter is feet, so the only thing that is left is this horsepower thing. I don't know anything about thrust. I'm sorry. So I have 600 equals, okay, that's probably why I was a math teacher, so I didn't have to know all that stuff. S we decided was speed, and that's RPM. So which piece of information is a speed and RPM? There it is, 1000. And D, diameter in feet, 4 feet in diameter, 4 squared. This one works out a little nicer than the other one at least. So I have 600 equals, I can go ahead and take 1000 times 16. I know a lot of you would have done that already. 600 equals 16,000 K. Divide both sides by 16,000. We're going to get a little number. Looking for a K value. Divide by 16,000. 0.0375. I did not round. That's the entire value that they gave me. Plug it back in here. I'll go down below now. T equals 0.0375 SD squared. Now let's find the question. How much thrust? I just figured out that was T. Would a 5-foot diameter propeller generate at 800 RPM? Okay, this is just plugging things in. T equals 0.0375, which should already be in your calculator if you don't clear things out. Speed is 800. And 5 squared, some people would have just even jumped in there and put 25. Don't lose your exponent. That's guaranteed to make you wrong, and that stinks. Times 800 times 25. You get 750 horsepower. Yeah, I got the right answer. I hope you did too. Alright, number 7. I think this is the last one for the notes, so you guys are all relieved about that. I'm going to go ahead and clear all the annotations. Okie dokie, maybe. There we go. Recall that the weight of a board can support varies directly as the width and the square of the thickness and inversely as the distance between supports. Yucky yuckers. Okay, so that is when I saw those words, varies directly, I'm like, okay, let's find my equation. Weight varies directly, so that's K as the width. KW, oh, this is an issue. Do you guys see this? Weight and width. Okay, so that sucks. So let's not use W twice because that's just asking for trouble. So I'm going to change weight to L for pounds, even though I don't know why they use L for pounds. That's what I'll do. Okay, so now I have pounds varies directly as the width and the square of the thickness. So that's thickness squared. And inversely as the distance over D. Let's make sure I did that right and didn't lose any accents. Recall the weight, because where it varies directly as the width and the square of the thickness, got it, and inversely as the distance. Okay. A board with 8 feet between supports, 1.5 inches thick, and 5.5 inches wide can support 225 pounds. Okay, I have feet here and inches there. Let's commit to inches, people. 8 feet is the same thing as what? 12 times 8. 96 inches. So, the board with this between supports. That was D for distance between supports. So, distance is 96. So, I'm going to work and define K here. Equals, this is 96. 1.5 inches thick. I need to move my little recorder thing here. 1.5 squared, thickness was squared, and 5.5 inches wide. That's 5.5. Can support 225 pounds, so I should have had 225 here. Let's figure out what K is. Okay, this one's one of those yucky ones again. Let's multiply both sides by 96. 225 times 96. I get 21,600 equals K times 5.5 times 1.5 squared. Divide both sides by this mess. 5.5 times 1.5 squared. I'm so excited to figure out what K is. I'm sure you are too. Divide by, what do you need to remember? Those parentheses. 5.5 times 1.5 squared, closes parentheses up. And I got a K value of big numbers, 1,745 and decimals. Don't cut those decimals out. Keep them in your calculator if you can. 4545, looks like 45 is repeating. Okay, so now I'm going back to my problem. L equals 1745.45 repeating. W T squared over D. How much weight can the board support? So I'm looking for this if its width is increased to 7.5. So everything else is going to stay the same. So now I'm looking for 1745.45 repeating. The width was increased to 7.5, so this is 7.5. That was the only change, so the thickness should be the same. If you recall, the thickness was 1.5, and that value needs to be squared all over the distance between the supports, which was 96. Straight calculator problem. Be careful. Don't let your calculator get you down. You need to know how to type this in. My K value is already in my calculator, so now I'm taking it times 7.5 times 1.5 squared. I will hit enter before I hit divide by 96. And I get, I'm so smart, 306.8, and it was actually 18, and that looks like it's repeating. So 81 was repeating there. And what are we talking about? We were talking about L, and if you recall, I got that from pounds. Okay, that was super fun. And guess what? Last problem from the chapter. Yippee! I don't know how to spell yippee. Is there 2 P's, 2 E's? I don't know. Let's just go overboard with letters. Okay, that's it for chapter 2. I'm sure chapter 3 will be just as exciting as this one was. It's in the book.